Hi everyone, welcome again to the online training on Mangrove Health Index. I wish you are well and stay healthy. We are still happy joining this training. My name is Yaya Ihya Ulumuddin. You just call me Yaya. It is an honor to know you and see you in this session. Hope this is not the first time and the last time I see you. Hope this can expand our networks with mangrovers around the world. And today I would like to introduce you a Mangrove Health Index that Indonesia through LIPI has been formulating since 2018. So in this sessions we have two parts. First, I will introduce you about the narrative of Mangrove Health Index, or the theory about Mangrove Health Index, and then we move to the practical. We're gonna practice how to calculate a Mangrove Health Index based on the available data, and then we create a map of Mangrove Health Index using Sentinel data. Alright, so why do we need a Mangrove Health Index? So if we are talking about mangrove management, yes, we already have mangrove extent. We can calculate the extent when finish mapping the mangrove area. But how about the quality of mangrove ecosystems we have? How can it be measured? How do we value our mangrove? Things like mangrove coverage, biodiversity, ecological functions and services. It must be many aspects that reflect the quality of mangrove. However, in mangrove management, in management practice, we need a single metric that could represent all the value of mangrove. So then when we combine this metric with mangrove extent, we could easily locate the degradation area or potential area for rehabilitation, conservation area, and so on. This is very important, especially for mangrove management in the national level. So here we define Mangrove Health Index as a single metric, measure, or parameter that can represent, reflect, and show the quality of mangrove ecosystems like ecosystem function, ecosystem services, biodiversity, and etc. And also it can be compared among sites or among different times. So when we formulate Mangrove Health Index, we think the Mangrove Health Index, the index should be simple and practical, but still reliable. And also it can be integrated with spatial data, so we could have a map of Mangrove Health Index. Then we can have the extent or the quantity of mangrove health, the quantity of mangrove, and the quality of mangrove ecosystems. And this is the proposed formula of Mangrove Health Index. And here it contains three simple parameters such as canopy coverage, diameter at breast height, either sapling or tree, and number of sapling per area. The formula is based on simple mathematical equations, which is an average of the three parameters. So because the parameters has different data range, so firstly it should be standardized so that they have the same range of data sets between 0 to 10. We define the new value of the standardized parameter as score. Then to make Mangrove Health Index range between 0 to 100, the average of the three parameters is multiplied by 10. Alright, leave this formula here If you don't understand, don't worry. I will explain more detail later. Hope you can find the way to understand soon. Alright, so things again that the formula should be simple, practical, and reliable. Therefore, the first things we do is of course looking for the basic theory. And then we found in two papers, McElhinney et al. 2006 and Storch et al. 2018. So that's why we may guarantee that the proposed mangrove health index is reliable. And then we value the quality of mangrove. We think surrogate parameters, but there should be only several important parameters. As suggested in the papers I mentioned before, we use principal component analysis to select the domination parameters that characterize the quality of mangrove. With this approach, we found three main parameters, so it makes the formula of mangrove health index is relatively simple like this. Then we try to integrate this mangrove health index also into spatial data, Sentinel-2 imagery, so that we could create a map of mangrove health index in the end. So if we could do this, our mangrove health index could be easily to use for management actions. We could look at which mangrove area is good or bad, how is the extent of good mangrove area, and so on. So in the following slide, I will explain in more detail about the process of mangrove health index development. So when I was looking for the basic theory, firstly we found a paper discussions about mangrove quality index that developed in Matang Mangrove, Malaysia. This is very inspiring, and because mangrove quality index is really comprehensive to assess mangrove ecosystem health. So in this mangrove quality index, besides 10 structure parameters, it also involves soils and hydrological parameters. It means we need to do lab work for soil and hydrology assessment. Because of this, we decide to find out the other approach that may be simpler, and finally we end up with the McElhinney and Storch. In these two papers, they use a stand structural complexity concept to assess the quality of mangrove forests. So if variety of forest structural components are considered to have a variety of resources and species that utilize these resources, therefore there is often a positive correlations between elements of biodiversity and measures of the variety and or complexity of structural components within an ecosystem. It means that structural complexity measures could be correlated with not only biodiversity but also ecosystem function and services. Or we can say it the quality of an ecosystem. So that's why we think by measuring stand structural complexity, it also can measure the quality of an ecosystem. And we developed Mangrove Health Index based on dataset acquired from 30 monitoring locations, 831 plots, 10 meter times 10 meters. For the first times, we selected parameters of stand structure this is not only has been agreed by many researchers in Indonesia during focus group discussion in the making of Mangrove Health Index, but also it is grounded to the theory in the papers I explained before. Then we have canopy coverage, stand height, diameter at base height, basal area, number of tree, number of sapling, number of seedling, number of tree and sapling, and so on. All these parameters related to the stand structural components. Based on those datasets, firstly we run principal component analysis many times with the different combinations of parameters. For example, this figure show unclear grouping of plots. If we choose coverage, height, diameter, and number of tree, as you can see, many groups are highly overlapped, shown by the ellipse with different color and size. And this is also showing unclear grouping. But here we found much better grouping. The figure shows the canopy coverage. Look at the z-axis here. It is highly characterized the variety of stand structures of mangrove. A variety of mangrove quality is represented by the ellipses, and the ellipses are along the C line here. So that on top, ellipses are highly overlapped. That must be okay, because on the bottoms it less overlap. It means there is much better grouping, and we can interpret that we may have clear differentiations of the stand structure span, especially for the groups on the bottom here. So we choose these three parameters that may be good for Mangrove Health Index we are going to develop. Then, for formulating Mangrove Health Index, first we have to do scoring for the parameters, because the data sets of parameters has different ranks. So we do standardizations data sets. The standardizations that was done by corresponding each value in the data set of parameter with value from 1 to 10 based on its percentiles. For example, first percentile corresponds with score 1, second percentile corresponds with score 2, and third percentile corresponds to 3, and so on. From this, we create the regressions, and then once we have a formula, like here, score canopy coverage equal to 0.25 multiply canopy coverage minus 0.086. So we can estimate the scoring for the other data points. So if we have done standardized the data sets, then we could calculate Mangrove Health Index based on this formula. And this is an example of the Mangrove Health Index value at the sampling plots around Indonesia. Yellow dot represents the low value of mangrove health index, and the red dots represents the high one. If we zoom to the area that I circle in the corner, you can see how match the mangrove health index with the conditions of mangrove in the field. So in this figure, the background is being mapped satellite image, and you can see the difference of coverage, mangrove coverage from the sea on the left to the land. There is a different canopy coverage which clearly match with the value of mangrove health index. For example, the yellow one, that's the low value of mangrove health index, which is corresponds with the low density of coverage here. Then we try to find out the correlations between mangrove health index and spatial data. Here we use sentinel data, and we choose mangrove vegetation index proposed by Baloloy et al. 2020. I bet you know this mangrove vegetation index that you have learned already from previous sessions in this training. So first, when we have a mangrove health index with the coordinate locations, and we can locate and measure or extract the value of mangrove vegetation index from Sentinel-2, and then when we have all the data sets, we can calculate, or we can analyze our regression. We can create formula from that regression analysis, and here we found the R square of the formula is 0.5, which is we could say reasonably good. And then using this formula, we can create map of this. Oh, I forget that the data we extract for regressions analysis is based on the field sampling in this area in Segara Anakan Lagoon, East Java, Indonesia. And then using that formula, I calculate back into the Sentinel-2, and then we have mangrove health index maps like this. As you can see, the green one is have a high value of mangrove health index, and the yellow to red, that's the low value of health index. That's reasonably good, and I wish I could do this for another area in mangrove in Indonesia, or maybe in the other region in the globe. Alright, this is what can I share for the theory of mangrove health index today, and thank you very much. And now we do practice how to calculate mangrove health index and how to create mangrove health index map. Thank you. Alright, let's move to something more practical, which is calculations of mangrove health index, and then making a map of mangrove health index. First of all, you have to open the Excel file, MHI training. This is the field data, the data set from Segara Anakan Lagoon in West Java, Indonesia. We collect some plots. It's about 39
substrate, and this is the parameters that we have already measured in the field, like canonic average, height, stand height, diameter, number of tree and sapling in total, number of tree, number of sapling, species name, and then here we provide 3 columns for calculating score of canonic average, diameter, and number of sapling, and the last column here for calculating mangrove health index. So before we do the calculations, we have to look at the formula again. So the formula MHI, actually the average of score 3 parameters, selected parameters, multiplied by 10. And before calculating mangrove health index, we have to calculate score of each parameter based on this formula. But you have to remember that the range of dataset should be the score dataset should be from 0 to 10. So if it's less than 10, the score of canonic average less than 10, so should be changed. The value should be changed into 0. But if it is higher than 10, the score of canonic average should be less to 10. Same things to do when we calculate score for diameter and score for number of saplings, like this. So if you understand how to read or to interpret this mangrove health index formula, you can move to translate this formula to the syntax, actual syntax here. To do that, we are using if function and end function. So in this case, we have one nested if functions on it. So for the first if functions, we have the first statement here. This is the statement, and then this is the logical true, and this is the if logical false. And then because of the if logical false is if functions as well, so inside the if functions we have the statement if the formula, or this formula score of canonic average formula equal less than 0, so the value should be 0, otherwise should be 10. This is for the false value, 0 or 10. And then for the first statement here, actually it covers the value between 0 to 10. If the result of the formula of score canonic average between 0 and 10, so the true statement should be the result of the formula. Now move to the false conditions. That's the logic of the syntax. Hope you understand that. Okay, then if there is no problem with the writing of this syntax, it should be the value for these plots 7.4. But if you doubt with these calculations, you can try to calculate it manually by hand or using calculator. the same thing for score of diameter and score number of sapling. And of course, you have to remember the formula is a bit different. You have to focus on it, and then don't forget about the cell number like this. Okay, so when you finish calculate all this score of the parameters, you can calculate MHI using the average of these three values and multiply by 10. The average multiply by 10. That's it. This is the value of Mangrove Health Index for this S706 plot. And for the rest of plots, you just copy the formula using this approach this way. Drag it, lock first, and then drag like this. And that's it. You have all the value for all the plots. Okay, and finish, and don't forget to save as. And the next steps is we need to use this value to make an interpolations using spatial data. We're gonna using Sentinel data to interpolate this MHI, and then we can create the map of MHI. To do that, first we have to save this file into CSV format, comma delimited, this one, name, just put the same name, and save it, finish for this stage. And let's move to QGIS. And first of all, you have to open the MHI. I hope you have already downloaded this file from the LMS system. MHI. Maybe you can download it using what we have already provided for you, or you can use what you have done from the previous session in the training. I thought you have already done it because my the other tutors train you how to make this raster file of MVI, Mangrove Vegetation Index. That's from Mangrove et al. 2020. So to make it a good appearance, you can change the range of value. Maybe you can use the single band shadow color and change the minimum and maximum of the value. 0 to 25, and it's much better looking. Then and this is a MVI, so if we look it closer to one area, for example, you can find this is range by pixels, and each pixel has one value here, like 7.1, here 6, here 4, 3, etc. So each pixel has our value of MVI. So the idea of the interpolations is we need to have a formula based on regression analysis in MVI and Mangrove Health Index for MHI. So then we call the MHI first. MHI we have done before. This one should be like this. Add finish. So it's better we change the color. Where's the color? Change the color so you can see the points. So this is the points of data set from the field. Show you the attribute of the table. This is exactly the same with the Excel we've done before. It's number, code, plot codes, location, substrate, parameters, and species. And this is what we have done already recently done here. Scores. Then, if we look at the closer to the one points here, then we using this identify cursors, and we can see in this panel MHI value 44.3, and if we click the pixels on it behind these points, we can see the MVI value 6.25. So this attribute value that's come from field measurements, CHD, and this come from field measurements, and MHI is from the calculations of these measurements I showed you before, right? And then let's move to another plots here. Different value of MHI, and it has also different value of MVI. So when we are going to make a regressions analysis, we have to extract the MVI value for every single plots that corresponds to the MHI training, MHI value. So how to do that? You can use this feature, and then write down the sampling, there are sampling raster value. You can use this feature to extract the value of MVI in the points in this dot. Okay, so input point layer is MHI training, so it corresponds between, we can correspond between MHI and MVI. And then raster layer to sample should be MVI. And then output column prefix, it's better we say MVI, so we know that columns is MVI value, and save it in the new file. It's better. New file, you can say put in the same folder. I name this file MHI MVI, so the data sets will contain MHI and MVI in the same file. Save it, worry, we can fix it. Lock this column and then click data menu, go to text to column, and then next, comma, next, and finish. Come back to like Excel. Okay, don't forget to save this file into Excel format so you can have it like Excel. Done. You can see here this column. This is from previous file, and this is the new one, MVI one. See, so we have the datasets of MHI and we have dataset of MVI. Then if you want to do regressions analysis here, it's very easy. Just using chart like this. It's better we change the X and Y because I will tell you later. We need to change versus letter icon. Q here. B here. B here. Finish. And this is MHI, and the x-axis is MVI. X-axis MVI. It's better I add the format. No, design. X-axis is MVI as the predictor. It's MHI. So when we use this menu, we have the equation. And then R square is fairly good. We can use this one. So we can change this one with MHI because MHI is Y, and then this MVI. Just like that. So from this formula we can calculate back this file, this raster file, so we can estimate the value of MHI in the every single pixels on this MVI mangrove vegetation index. Okay, how to do that? You just remember. You can back to the formula. Remember it. 5.1703. Okay, 5.1. And using this raster calculator. MVI multiply by 5.17 that's it 03 plus 20.256. 20.256. And then name the raster file MHI. Save it and then okay, it works. Oh, okay, because we know that the range of MHI is from 0 to 100, so we have to change it 0 to 100, and then you can change the class of this. I choose equal interval, and then I choose classes 3 is enough, then change from 33 and then 67. Okay, apply, and voila, this is it. So this is, we have the map of MHI. So you can use this to check which one is bigger and which one is lower. So actually you can see from this panel, the red one it's low value of MHI, Mangrove Health Index, and the yellow one is medium, and the blue is the highest value of Microfault index. Move this one so you can see the distributions of stations when we did field work in this area. So this is the last of practical of these sessions. I hope you can follow what I have already shown you here, and then maybe later we can exercise more, and then we try to make a map for the other place, maybe in Indonesia or in your country. Okay, thank you everyone. If there is any questions, you can jump up when I give a presentations, give a lecture tomorrow.